Okay, let us continue the discussion. In the previous session, we have seen the trapezoidal pulse, how we calculated the energy, total energy. The total pulse x of t, it is divided into three different lines. This one slope, the second constant line, and this is the third slope. For these three, considering these three lines, we have found the equation for x of t. Okay, we have used the straight line equation concept. We have found the equations, and this is how we find the x of t signal. And once x of t signal, you can define it in the form of equation, it is easy for you to find the energy afterwards. Okay, energy, you please try to go through the calculations. You try each step, apply the integration, apply the limits, have patience, try to solve this, simplify this. You should get a 26 by 3. Okay, continuing the discussion, this is one more question from your Simon Haykins exercise textbook problem. The same trapezoidal pulse which we discussed in the 7th question, the same pulse, if we apply this to a differentiator. Okay, I had told you when I was discussing regarding some of the basic operations performed on the signals, we have done addition, scaling, subtraction, multiplication. After that, differentiation and integration. And I had told you, while dealing with few problems, you will understand how this differentiation is done on the signals. Okay, if you remember, I had told you, while solving the problems, you will understand the differentiation operator. So this is one application of that. Okay, this problem, this involves the differentiation operation on the signal. So what the question says, if the signal x of t is applied to a differentiator, how the differentiation operation works? Any output, it is given by d by dt of x of t. The variable is time, right? I think in your differentiation, you generally take d by dx, okay, where x is the variable. But यहाँ पर signals में आपका horizontal axis जो है ना, that is time. So for that, you take d by dt of. Okay, this is the differentiation operation. So what we need to find? Find the output y of t. So if this is the relationship between y and x, we need to find the output of the differentiator, first thing. And second, find the energy. Energy, just now we have calculated the energy of x in the previous question. Now we have to find the energy of y. Okay, after applying for the differentiation, what output we get, on that output, what will be the energy? So let's start solving. See, I have not repeated it. For the pulse, directly I have written the equations. So you should know now how these equations have come from. From the question number 7, these equations we have found out. For this particular line, we have used the straight line equation. Then this is a constant, that one I have written here. And this straight line, we have used the straight line equation form, and we got this equation, and 0 otherwise. So this is the equation x of t we got from the figure. Okay, in the examination, if this question is asked, you can't by heart these lines. Okay, the points may be different. So according to the question, you have to first frame x of t. From the figure, get the equation for x of t. That is your first job. Here I have directly derived from the previous question. Now, according to the first sub question, we need to find the resulting output y of t. So what is output y of t? It is the differentiation of x of t. What we have to do? Simply take the x of t and differentiate it. So if you differentiate 5 plus t, what will happen? What is the answer? Differentiation of a constant is 0 plus differentiation of t with respect to t. With respect to t, it is equal to 1. 0 plus 1, you will get 1. Then what is the differentiation of a constant? It is 0. Differentiation of 5 minus t. Differentiation of 5, it is a constant term, 0 minus differentiation of t, that is dt by dt, is 1. Hence it is minus 1. So what I did, x of t, I have already written the equations, but y of t is differentiation of x of t. So whatever x of t equations I have simply differentiated each equations. Okay, we will get 1, 0 and -1 for different time ranges. Okay, so can we draw this? Can we draw can we try this drawing this y of t? Let's see. It says first you have, see, limits are -5 to +5. What I will do, I will take the horizontal timeline -5 to +5. This is the extreme range. Between -5 to -4, the amplitude is 1. Between -5 and -4, the amplitude is 1. One pulse will come. And between -4 and +4, see, between -4 to +4, you don't have any amplitude, it is 0. So I have not drawn anything, it is blank. And between 4 to 5, if you observe, between 4 to 5, the amplitude is negative, -1. So a negative pulse I have drawn. This is -1. This is how I can draw y of t. They have not asked you to draw y of t, but however, we can try drawing. Okay. Now, what is the second sub-bit, sub-question? We need to find the energy of y of t. Already we have the equation of y of t with us. So, find the energy for this. We have the formula for the energy. Energy is integration. General range is minus to plus infinity. The signal square dt. This is general signal x of t. Okay, I have written the formula here. But however, in case of our question, it is y of t. So energy is, check this figure. You have only two values. This is +1. This is -1. Time range is -5 to -4. See, between -5 to -4 +1, the signal square dt plus, and you have a -1 amplitude for the range 4 to 5. So integration between 4 to 5, you have -1 square. So simplify this, apply the integration. Integration of 1 is t, and apply the limits. Integration of -1 square, again it is 1. Integration of dt is t. Apply the limits. If I solve this, I'll get 2 joules. This is the even question paper problem as well as exercise problem. Okay, this is a repeated question, I guess. Fine. Question number 9. A rectangular pulse x of t is given by x of t equals to, see here they have not given you the figure, they have given you the equation. Sometimes either signal is given to you, you need to form the equation, or sometimes directly equation is given to you. It is up to you whether you want to draw the signal or not. So x of t is given between 0 to t, some range is given, amplitude is a, some general amplitude a, and it is 0 otherwise. I have drawn the signal here, you can see. Between 0 to t, one constant amplitude a. I don't know what is a, general amplitude a, and 0 otherwise, no other amplitudes. Only between 0 to t the signal exists. Okay. So what is the question? It is applied to an integrator. See, again it is one of the application of the operations performed on the variables, wherein differentiation and integration both have to be performed. In the previous question we have seen how to perform differentiation. In this ninth question we will be seeing how integrator works. Okay, a general equation for the integrator they have given you. As already small t and capital T both variables have used, so they have taken one more variable just to differentiate. It is also representing the time only. It is tau value or tau, what you say. Okay, integrator range is between -infinity to t. Okay, no future, only up to the present, -infinity to t, x of tau d tau. This is how integrator works. So we need to find the energy of this integrator output, y of t. So in the previous question what we did, x of t, we had the equations, we differentiated the equations. Fine. In this problem, Already x of t they have given you. Just integrate the equations. See, x of t is already there. Integrated. Integration, the equation is also given to you. Minus infinity to t, x of tau d tau, wherein our lower limit will change to 0 because the signal range is, see, it starts from 0. So the lower limit will be 0. I will not touch the upper limit. It is a general limit t in the formula. I will not change this upper limit formula. I will simply touch this lower limit, that is 0, because our signal is not an infinite signal. It is a finite signal. So 0. And what is x of tau? It is given here. Amplitude is a. So a into d tau. So integrate a. What is the integration of a constant over the variable tau? Integration of d tau is tau. So a is a constant. Keep it as it is. Integration of d tau is tau over the limits 0 and t. Apply the limits. A as it is, t minus 0, you will get at. This is your y of t. I have found your y of t. Y of t is what? Integrator output. Now I have first calculated integrator output. Then I have to find the total energy of this integrator output. How to find that? We have the formula. Integration minus to plus infinity, the signal amplitude square dt. Now what is the signal range given? It is 0 to t. And output, just now we have calculated y of t. It is a into t. It is a square. So a square into t square. Now a square is a constant term. I'll keep it as it is. What is the integration of t square? It will be t cube by 3. T cube by 3 over the limit 0 to t. Apply the limits. Lower limit will go. Anyhow, it is 0. See, it is simply a square t cube by 3. Energy is there. So it is in joules. Now, one more straight line kind of a question. Let us see. We need to find the average power of this triangular wave. So we need to find the power here. So straight away power is asked. It means the signal is periodic. The signal is infinite. You can observe it. I have not written the dots. You can just assume it. They both are extending from minus to plus infinity. So it is infinite signal. It is periodic signal. We should go for power. If you observe in the given triangular wave, we have straight lines. See, the lines are there. So again, from the figure, we should extract the equation for the straight lines, just like how we did for trapezoidal pulse. The difference is that signal was finite and we found the energy. Here the signal is infinite. We have to calculate the power. But otherwise, the concept is the same. We have straight lines here. See, combination of two lines. There is one slope increasing, one slope decreasing. If you just combine these two, you will get a triangular wave. So once you find the equations, it is easy for you to calculate the power. So let's see. And one more thing, you can start at any point. In the figure, you can observe, I have taken this line. Okay, these 2 points as one line and these 2 points as second line. After that, the signal is repeating. This is a repeating term. Okay, it is repeating. So I will take only 2 lines. But however, you can start at any point. You can take this as your one line, this as your second line, and calculate. The answer will remain the same. But anyhow, you know, it's a standard thing, start from 0. So I took this as the first line. But however, you can start at any point because anyhow, the combination of lines will give you the triangular wave. Okay. So if you observe here, for this particular straight line, let us try to find the coordinates. What is the coordinates of these 2 points? Because it is important for us to find the coordinates. Then only we will be able to get the equation for the straight line. Now, check what is the horizontal axis here. If I'm here at 0 position, I have whether I have moved here any horizontal position. No, I did not move. I have only moved vertically down, right? So horizontal value is 0, vertical -1. So I have reached at -1. So the coordinates are 0 and -1. Similarly, if you see this point, to reach this, I'm here starting at 0. To reach this point, first I will travel and I will reach here x axis, which is 0.1. So x coordinate is 0.1. Then to reach to this point B, I will travel this vertical direction 1. Hence the y coordinate is 1. So the coordinates are 0.1 and 1. So this is how for this line we will calculate the coordinates. Now this is for straight line 1. Now for the straight line 2, you take this 2. Already this point we have done. Let us see how to reach at this point. Assume that I'm here. What I will do, I will travel up to point 2 in the x direction. So x point is point 2. Then I will travel down negative direction to 1. Hence it is -1. So the coordinates are 0.2 and -1. So now we have seen, now we have got all the coordinates. Okay. And it is a convention. See, if I have a line like this, I will take this as the first point, this as the second point. And if I have a down straight line like this, I will consider this as the first point, this as the second point. This is the convention that generally we use. Okay, once we got these coordinates, let us find the equations for the straight lines. I have done that here between 0 and 0.1. That is between 0 and 0.1 means this line I'm talking about. Okay, for this line, two coordinates are already there. What are there? 0 and -1, 0.1 and 1. These are the 2 points. The same thing I have written here, 0 and -1, 0.1 and 1. So I will use the again straight line equation 2-point form. Y minus y1 by x minus x1 is equal to y1 minus y2 by x1 minus x2. This is the straight line equation. So points are x1 y1 is 0 and -1, x2 y2 is 0.1 and 1. So what you need to do? Put all the values, x1 y1, x2 y2. Substitute all the values except x and y. X and y indicates the line equation. At the last, we will replace it. So if you solve it, you will get, I did not write the sign, it should be negative. Okay, it is y equals to 20x minus 1. You please solve this, you will get it. Okay, y equal to 20x minus 1. Now what is y? If you have a coordinate system like this, horizontal axis is time, vertical axis is your signal in signals and system. So y indicates x of t, I have replaced it, and x indicates time. So x indicates time. So 20t minus 1. So this is first equation. Similarly, we have just now calculated this straight line equation. Similarly, try this equation. To find the equation for this, consider this as x1 y1, this as x2 y2. So 2 points are already there with you. You have a straight line equation. See, I have calculated. This is your line equation. x1 y1, x2 y2. x1 y1 is 0.1 and 1. See, 0.1 and 1 is x1 y1. x2 y2 is 0.2 and -1. 0.2 and -1. So with these points, if you use this this line equation, substitute all the values. What I have done, I have cross multiplied the values, and if you simplify this, you will get this much. Y equals to some -2 by 0.1. -2 by 0.1 is nothing but 0.1 is 1 by 10, right? So 10 into 2, you will get 20. Similarly, 0.3 by 0.1 is 3, right? 3 by 10, 1 by 10. So 20 x plus 3. What is x? X is horizontal axis time. Y is vertical axis x of t. So from the straight line equation concept, I have found these two straight line equations. Once I get the equations, it is fine, easy for us to calculate the power, because question is to find the power. But for the power calculation, we should know what is the fundamental period. That is, after what time the signal repeats. So what I will do, let's try calculating. Let me start from 0. See, this is one straight line, one more straight line. After this, the line is repeating. So this is your time period. Calculate what is the time range between 0 to 0.2. So it is 0.2 minus 0. This value minus this value, you will get 0.2. You can try finding it starting from any point. Let me show you. If I take this as the starting point, what will happen? One line, second line, and after that the signal repeats. Okay. So if I start at this point, take this is one straight line, this is second straight line, after that the signal repeats. So this is the end. So just try to take the difference, 0.3 minus 0.1, you will get 0.2. Okay. Take one more. I will try with this. Let me start at this point. We have one line here, slope, one more slope. After that the signal repeats. So 0.1 minus of minus 0.1. So plus, right? 0.1, we have to subtract the points. This is your 0.1 minus, this is your minus 0.1. So again you will get 0.2 as your time period. So try calculating the power. From this straight line equations, we have written the equation for the given signal x of t. Power, how to calculate? 1 by t, some integration of minus t by 2 to plus t by 2. You can take 0 to t also. X of t square, signal square into dt. Now, if you see, 1 by t is 1 by 0.2. Okay. And integration is over the limit 0 to t. So 0 to time period is 0.2. Just now I have shown you how to get that time period, 0.2. Or you can take minus t by 2 to plus t by 2, that is 0.2 by 2, 0.2 by 2, minus 0.1 to plus 0.1. No issues. You will get the final answer same only. And x of t signal, it is divided among two integral limits. So what I will do in the next step, 1 by t, which is 1 by 0.2, which is 2 by 10, 10 by 2, which is 5. So I will write this outside. This complete integration, I will divide it. Two limits. One limit is 0 to 0.1, 20t minus 1, the signal square. And the second limit, 0.1 to 0.2, which is minus 20t plus 3, whole square. Okay, total time range is divided among two straight lines. Then only we got the triangular wave. Now the simplification step comes. What I have done, 5 throughout I have kept outside. Finally, I'll multiply. What I did, a minus b whole square formula. Apply. After that, apply this integration to all the three terms. I have applied, see here, 1 term, 2 term, 3 term. Then again, apply this integration to all the three terms. 1 term, 2 term, 3 term. You should be very careful because fractional points are there. So you may get it wrong. Okay. So be careful while solving this problem. Try to do it by yourself. If you see, after this, apply the integration. Integration of t square is t cube by 3. Integration of 1 is t. Integration of t is t square by 2. Integration of t square is t cube by 3. Integration of 1 is t. Integration of t is t square by 2. So after this application, I have applied the integration. Okay. After applying the integration, we should go for application of limits. So if I apply the limits, be careful. T cube, 0.1 cube minus 0, 0.1, 0.1 square. So when you are calculating the cubes and squares, be careful. So don't write 0.1 into 0.1 into 0.1 is equal to 0.1 only. Okay, it is 0.001. So be careful, try to use the calculator, try to solve this. After solving, I got 18.33 joules per second as the answer. You try by yourself. For this particular straight lines, triangular wave, combination of these two lines, when you solve it, you should get this much. In your one of the textbooks, this problem is, direct answer is given. It is given as 1 by 3. But I did not get 1 by 3. I got 18.33. Let's see if any one of you can get this 1 by 3. Hopefully, I'm right. 18.33 is the answer. You try by yourself, okay? You can see it on the screen. Next question. The angular frequency of a sinusoidal signal a cos omega n plus 5, it satisfies the condition of periodicity. It means they have given you that it is periodic. Cos signal hai, it is periodic. Okay. And we have to find the power. So already it is given. Directly take the power equation. P equals to 1 by n summation 0 to n minus 1 signal square. And 1 by n summation. What is signal? Signal is already given to you. A cos. So a square cos square. At the max, what I can do? Cos square is 1 plus cos 2 theta. Substitute and put it. No further answer. It's only this much. You can further solve it by applying 1 plus cos 2 theta. Okay, that much. Next problem. Find the energy of the signal. So already equation is given to you. No figure. Equation is directly given. You need to find the energy. So energy is equal to some integration. General range is minus to plus infinity and signal square. So what is the signal range for your given question? It is divided among two, 0 to 1 and 1 to 2. So what I did, I will split this total integration into two parts, 0 to 1 and 1 and 2. For 0 to 1, it is t. So that's why it is t square. Don't forget the square. And for 1 to 2 integration, for 1 to 2, it is 2 minus t. So 2 minus t square. Don't forget the square term. Okay. Next is simplification. What I did, t square integration is t cube by 3. This is a minus b whole square. A square plus b square minus 2ab. Then apply the limits. I will get this 1 by 3. Then integration of dt is t. Integration of t square is t cube by 3. Integration of t is t square by 2. After that, apply the limits, upper limit minus lower limit. If you take the LCM and solve the value, you will get 2 by 3. I got 2 by 3. You check by yourself by calculating whether you will get the same answer or not. Hopefully, you will get the same answer. Any doubt in this? Any doubt in today's two sessions? Please let me know. Okay, Tasleem is telling no doubts. Okay, hopefully you understood.